This one gets pretty tough to draw pretty quick. All right, so are you guys getting something like that?
Yeah.
I didn't do the outer ones just because those outer ones are getting super steep. It's going to be really hard to distinguish those from being vertical. Out there on the edges, the slope would be plus or minus 6. It's a really steep slope. So, a quiz or a test, I'm probably going to try to limit your exposure to like extremely steep or extremely almost horizontal slopes, but not quite, just because it's really hard to distinguish those. So that's why I kind of just included those. You guys have any questions on the slope field formation? You see the vertical pattern? Okay. Any thoughts on what a solution curve might look like for this one? Yeah, it is a parabola. It's a steeper parabola than the one we did on the video, but it is a parabola, and the so the solution curve could look. That is one of the better parabolas I've drawn in a while. I'm just going to leave that up there for a little while. Yeah, I'm going to like clap for myself. Usually they look like these misshapen, horrible whatevers. But yeah, that would be a reasonable solution curve based on whatever initial condition you had. And now it's gone. It'll come back. It'll come back.
Is it on YouTube?
It will be. Yeah, it'll be hopefully saved forever on YouTube. Okay, so any questions whatsoever about that? Okay, fantastic. Then please also take a look at 5. Let's look at 5 as also kind of a review sort of question based on what we did in the video and kind of what we did last time. I think 5 should be fairly straightforward. So please take a look at that. I will try to get there myself. Okay, take a look at what you've got. Is this about what you have as well? Not that. How about that? Check out what you have, check out what I have. We in agreement. Any thoughts on what the solution curve might look like for that? Exponential is right. It is exponential. So depending on what your initial condition was, the solution curve could be up here somewhere. Oops, I froze it. Could be up there, or your solution curve could be down here. It would just depend entirely on what your initial condition was. It would put it below or above the horizontal asymptote. Okay. No, that's a great question. If you did draw both, then what you have there would not be a function. And we're going to find out later that for a solution to a differential equation, there we go. The solution to a differential equation, particular solution, has to be a function on the largest interval that contains the initial condition. And so that would fail the vertical line test, so it wouldn't be a function anymore. So you're going to find that if you start to curl back under and you're going to have like failure of the vertical line test, you should have stopped in there somewhere. Or if you have something like this where there's two pieces, you should have just picked the one that has the initial position. We'll get into that a little bit more later, but that's the idea. All right, so then the final slope field drawing activity for us is back up here, number 3. So number 3 will be, of the ones we've done today, the most challenging simply because dy dx contains or depends on both x and y. And so there will not be that nice tidy vertical pattern like we had on the first one, or the nice horizontal pattern like we had on the second one. There will be some kind of a diagonal-ish, there will be a pattern there for sure, but it'll be more of a diagonal pattern. So take a few minutes here. This will take you a little longer than the other one. You might have to test out some individual points. You should be able to see patterns. And once you do, you kind of get it filled out. And we'll see what it looks like here in just a second.
Yeah, it's that way.
It's a one-way guy.
That way.
Have you guys seen this pattern yet? It should show up. Have you guys seen that one yet? Where the slopes are zeros, kind of diagonals across there? Okay, cool. I'll let you keep working. I'll maybe do a few more here. Another look at a little more of a developed pattern. You guys seeing that?
Yeah.
Okay. Upper right segment. Does that look good? Kind of that upper right area, more or less. Really steep, man. Yeah, it's tough. Those are tough to do. Let's see here. Okay, so we have maybe the whole thing filled out at this point. What do you think? Does this look about right for you? Any features jump out to you as far as what might be some of the things a solution curve would have? A diagonal asymptote, yeah. Can you see it right there? Right there? Diagonal asymptote kind of cruising through there. So as far as a solution curve goes, solution curve could be something like that. Doesn't have to be that. Could appear down lower left. I mean, there's two main spots it could be. It really just depends on the initial condition. We're not going to get too stressed about that right now. Okay. Are you guys becoming pretty solid with these? Okay. Any last questions before we move on to the last little bit of slope fields? Okay. Good deal. Well, as I walked around and saw your slope fields, they do look good. So that's awesome. Okay, so let's move on. We're going to do a couple of activities with these. And here goes. So this, yep, this fits just about right. Okay, so this says match the slope fields with their differential equations. You can see you've got 4 slope fields, A, B, C, D, and you've got 4 differential equations down below. And the idea is to match the 4 numbers with the 4 letters. So I'd suggest maybe your first level of comparison here would simply be patterns. And if 2 patterns kind of go with maybe 2 different ones, and it's hard to decipher between the 2, you can start to plot some points on your slope field like we just did and see if they really do agree. So take a minute, see if you can match up A, B, C, D with 7, 8, 9, 10. Hey guys, get started. A, B, C, D, just love to hear from you guys what you think went with what and why. Any volunteers for 7? What do you think 7 goes with? A, B, C, or D, Zach? C. 7 goes with C, so let's see here. Why do you think that?
C looks like a sine curve.
Oh, okay, it's the only one that's cyclical. I think there's another reason. Say again? Process of elimination, sure. Did you guys see a vertical pattern with C?
The sign of 0. Yeah, zero.
Yeah.
So at 0, it's all that.
Yeah, but that actually,
Well,
so
it's the same with 10, but then you can plug in a 2. And
the 2, so yeah, let's talk about this. Do you guys see how C and B, there we go, C and B could possibly go with 7 or 10 based on the vertical pattern concept? They both have a vertical pattern. And so if you didn't see the thing that Zach said, hey, it looks like a sine curve, obviously. If you didn't see that, then you could do some test values and you could quickly say, hey, you know, when x is 1, when x is 2, I'm getting different things, and you could start to kind of decipher which one is which. But I think we're right on the money there with that. Okay, so how about number 8? Volunteers, which one do you think number 8 goes with? Go ahead, Hannah. D? Okay, why did you pick D? Right, and 8 is the only one that where dy dx depends on x and y. Okay, agreed. Number 9. dy dx equals 2 minus y. We're almost down to the elimination process here. Yes?
Okay.
9 goes with A. Why did you pick that?
There's if y equals 0, then it's 2, and that's still flat.
So you're really plotting points. You're like, hey, what if y was 2? What if y was 1? Et cetera, et cetera. And of course, you see the horizontal pattern too. Exactly right. And so then, by process of elimination, 10 does have to be B, but I hope that you would recognize that vertical pattern again, like we kind of saw earlier, and you could always plot a few points, like we've just been doing, in order to decipher which one is which. Okay, so C, D, A, B. Any questions on that one? Okay, fair enough. Let's move on. I think we got another matching activity coming up. We do. This one's a little different. Might be a little tougher, I don't know. So again, you've got differential equations down below, and you've got slope fields up above, and we are supposed to attempt to match. It was frozen that whole time, wasn't it? Doggone it. There we go. Okay, so those are those. So what did you guys match up? Hey, we're going to get started again. What did you guys match up with number 11? 11 goes with? B. Okay. $11 does go with B. You guys notice a vertical pattern? Was that your key on that one? Okay. Number 12. What do you guys think number 12 is? C, horizontal pattern goes with only y. But when you get down to 13 and 14, dy dx depends on x and y in both. And there's two that kind of exhibit this diagonal-ish, non-vertical, non-horizontal pattern. So what do you guys think? 13, what'd you go with? 13 does go with D, leaving 14 to be A. And of course, you could say, hey, I know that 14 is A is because we just did that one 5 minutes ago. Did we not? Didn't we just construct that? So that actually could have been a reason, I suppose. If you're ever having a hard time differentiating between which is which, I suggest you plot points. For example, this up here at that 1, 1 point is quite different than this one right here at that 1, 1 point. So a quick plug-in of 1, 1 would have told you which one was which pretty quickly. So if there's ever any confusion, I would suggest that. All right, so question?
Remember it's x over y, or y over x will be a circle?
No, because we did one the other day where it was a hyperbola. So yeah, careful about looking for patterns that aren't there. There are patterns, but just be careful. Okay, so we're going to transition. We're going to do one last one here, and this will be a little bit of a transition. Hey guys, listen. Hey, you need to hear this. The last two matching exercises we've done, we've tried to match differential equations with slope fields. In our final one here, this one right here, we are not matching differential equations with slope fields. We are matching solution curves with slope fields. Do you see the difference? A, B, C, D, and E, these are all solution curves because there is not a dy dx in there. They're all y equals. So this is a little bit of a different strategy. I will say this, that if you are really good with your parent graph concepts from back in Algebra 2 and pre-calc, this will end up being super easy. If you're shaky on that, it'll be a little bit tougher. If you're really shaky, you know what you could take A, B, C, D, and E and take them from being solution curves to being differential equations and basically do what we just did a few minutes ago. How could I go from solution curves to differential equations? Just do a derivative, yeah. So you could differentiate A through E, and then it would end up being the same thing we've been doing with slope fields this whole time, okay? So I'll give you just a minute here, maybe about a minute. See if you can kind of hash this one out. This will be the last one we do. The rest of the stuff in this early part of the notes packet, I'm going to leave as just kind of extra practice for you later on. There's a key to all of it in there, I believe, and you can just use that to get some practicing in. Say again? Yes. I'm going to try to make this work. Thank you. I got about a minute, right? Okay. So, real quick, does anybody know the answer to this one? What is it? It is natural log. Yeah, it is natural log. So, the answer to this is E. Here is one way you could go about this, and if you're struggling with this at all, maybe we could revisit this in the next few days. Here's how I would approach this. I would look at y equals x squared and say to myself, that's a parabola, right? And a parabola would look like this. Does that go along with the slope field? No. Not at all. By the way, that O right there means origin, right? You can see the y and the x-axis. Okay. Y equals e to the x looks like this. Does that go with the slope field?
Nope.
Not at all. Remember, the slope field should reflect the solution curve. You should be able to see it. E to the negative x looks like that. That sort of looks closer, but all the slopes on the slope field are positive, and all the slopes on that graph are negative, so that's definitely not it. Cosine of x looks like this. It would start here and drop down and do this. You can see that all the slopes totally don't match at all. And then finally, natural log's graph looks like this, and you can see that it actually does fit the slope field quite well. So from a graphical standpoint, we'd have to say that it's that. Okay.